So good evening to all our progressive weather followers that were not be able to be here this evening. So before we get to the monsoon, I wanted to take a look back at what happened this past winter. It's kind of an old wives' tale that if we have a La Nina season, we're going to have less than average snow. We had 3 La Nina seasons in a row. The first season, first I have to caveat too. In doing this study, I looked at the snow that was happening at Wolf Creek Ski Resort. And there's a number of reasons for this. And there's actually people there that are taking measurements. Their average for their seasonal snowfall is much lower than if you look at the Wolf Creek Pass numbers. Those Wolf Creek Pass numbers come from a period of time in which somebody was actually living up on Wolf Creek Pass. I think it goes back to 1908, Sean?
No, it's from the mid-1950s.
Okay. But there was periods of time when they weren't there during the winter, like 4 or 5 months, they would just take off. So for really scientific purposes, it would be nice to have a steady state sort of archive of data, but we don't have that. So when we talk about Wolf Creek Ski Resort, they're not there measuring snow early in the year, and they're not staying pretty much after the first weekend in April. So the average is going to be much lower. It's 348 inches over the last 43 years for Wolf Creek Ski Resort. So that's what I based my study on. So the winter of 2021, we had 362 inches. Just a little bit over average. I consider within 20 inches less or 20 inches more to be pretty close to average. Season 21-22, we had 385. Not bad. This past winter, Wolf Creek Ski Resort measured 490 inches of snow. A La Nina year. So I delved into this a little bit. And first, let's review quickly what is meant by an El Nino and La Nina season. So this is just a National Weather Service map that shows areas that are different than normal. This is not saying that up in Canada the temperatures are going to be warmer than what they are down in southeast United States. It's just saying that they're warmer than average for those locations. The same down in the southwest here, it's going to be wetter than average for that area. And if you'll see where we are there in southwest Colorado, represented by the little red star, we're really in between. That's not really showing that we're going to be wetter than average in an El Nino year. Nor is it saying that is a hard and fast rule. This is showing that we can expect in an El Nino pattern that the polar front jet is going to slip a little bit further south than what its normal location is during the winter. And that you can expect that the storm track, areas of low pressure, and the associated fronts then are going to be a little bit further south as well. And that's going to vary from El Nino pattern to El Nino pattern. Now if we look at the La Nina then, you see that the polar front jet moves much further north. And for us then, we can expect drier conditions. But we're right on the borderline. So if the polar front jet dips a little bit further south, then we start getting into that wetter and colder pattern. So that's one thing to look at. So I went back and I looked at all the numbers. And this is a very busy chart. And right now I'm putting together all this information into a winter outlook. For those of you that know Dean was at our library talk last week, and Dean asked that I put all these numbers into a post. So it takes me a little while to put together the post, but I'll get that out for everybody. And you can see, we want to really take a look at the La Nina. There were 17 events in the last 43 years. 6 of those events, we had greater than average snow. 6 of the events, we had less than average snow. And 5 events were pretty close to normal. Now, I'm not a math major. I did take statistics. That is not statistics argue that. And the same holds true for El Nino, and then also if we're in a neutral ENSO. So I did a little bit deeper in taking a look specifically at the last 2 winters. I can't go back and look at all the La Nina events that were greater than average because we're not really aware of what was happening during those winters. But the nice thing now that Mark and Sean and I are doing this every winter is that we can be checking and reviewing these events as they happen, and we can be recording it. So, with the winter 21-22 at 385 inches, a good 40-something inches above average. You can remember in December was phenomenal and really accounted for a good percentage of the snow that we had for that winter. And that was all due to a strong MJO event. And for those of you that want to learn more about the Madden Julian, come back in November when we really talk about these different winter oscillations and how they impact our winters. And at the same time, in February, we had a strong Arctic outbreak that impacted the snow as well. Now, this past winter, there's a number of things that happened. First of all, La Nina was weakening. We know that the waters were slowly warming, and we'll take a look at that again here in a minute too. And we had multiple weak MJO events. I don't see Lisa and Joe here tonight, but they were trying to plan a trip to Hawaii. So the 3 of us were tracking the MJO to see what was, and it would weaken, and it would seem that it had gone away, and it would reappear out there in the Western Pacific and come marching back towards us again. And then it would weaken. And so rather than coming back around every 30 to 60 days, it was literally coming around every 10 days, which resulted then in this nice big purple bump here in January. And then February was pretty normal as to what you would expect in La Nina winter, right at average though, which was great. And then into March, the thing to take into consideration is that at the same time, we were under a westerly QPO, which is a stratospheric wind, and I'll have more about that in my discussion in the post that I have. And I also have some numbers, in which I went back and I tracked how many times have we had a La Nina with a westerly QPO, and what was the result of that as far as snow. In almost every event where we had a La Nina with a westerly QBO, we had greater than average snow up at Wolf Creek. So that's good fun. The other thing that is of interest here is there was a little volcanic eruption. Steve and Jackie. The Hunga Tonga volcanic eruption occurred in January of 2022. And we don't know the impact of having all that ash up in the stratosphere as far as cooling the stratosphere as a whole and the impact then that has on our snow. I participated in an American Meteorological Society discussion, and I thought it was going to be more about the why California ended up with so much snow, because that's what I want to know. I want to know what their answers are to this. And they were telling more about the what. And I knew that California got a lot of snow. So they're actually giving grants now to a number of universities to go back and research exactly what happened in California. So as soon as I see that information, I'll be passing that on to you. And we'll see if it had more to do with the QPO or with the little volcano. So now, let's move on to talking about the monsoon. In order to do that, we have to do a little 8th grade science review. Now, who believes the earth is flat? see Sean after class. So there are 6 basic cells that are spinning around. For the most part, we live under the Ferrel cell, which is the winds out of the west. And with the winds out of the west, most of the systems move from the west to the east. However, when it comes to monsoon season, monsoon means backwards winds. Our winds switch from the west to the east, and we actually fall under the northern part of the Hadley cell, and the systems we're looking for are moving out of the east. So the basic building block for weather always is your air masses. During the winter, we love the maritime polar and the continental polar, the cold, moist, mixing with the cold, dry air masses, because that produces snow. For monsoon season, we are interested in the maritime tropical, both out over in the Atlantic and in the Pacific, and how they intermix with the hot, dry continental tropical. So as these air masses, they're born in these large, continuous areas that basically have the same sort of conditions. And then under these westerly winds, then they tend to move out. They form higher pressures, and in between then you're going to get low pressures. And it's the low pressures then spinning up that cause the frontal systems. And this is how weather happens. Sometimes they march along nicely and behave well, and then at other times you get blocking patterns. And these blocking patterns would help explain the weather that has been happening in May. But we're not here to talk about that tonight. So the monsoon pattern sets up with a large subtropical high out over here in the southern plains. And that draws the air in from the Gulf of Mexico, and then later in the summer, as the heat lows set up down in Arizona, it also draws the air in from the Baja area. And so that is a monsoon. So to say that we're having a thunderstorm this afternoon and that's the monsoon, that's technically not correct. The monsoon is a pattern that sets up, and it's a 3-month event. It starts in late June. You remember last year it started in the middle of June, right on time, and it didn't stop, it didn't let up. But usually it will sputter. 2 or 3 days a week, it will start, we're getting afternoon thunderstorms. And it might be when it first starts that just the folks on this side of the room will see any rain from it. And all of you over there are, well, I didn't see anything. So that's what we mean by sputters. In mid-July to late August, then we're into the peak of the monsoon. And we should see thunderstorms almost without exception. Throughout Archuleta County, there should be thunderstorms somewhere. And in those, then it's going to be just Ross that really isn't seeing a lot of rain. Everybody should see some sort of rain. We're looking at pulling in deep tropical moisture at that time. The monsoon ingredients, the first thing is we need real intense heating. This particular chart is a forecast for July, August, and September of this year. This is a European chart. This is one of these, when I talk about models, there are dozens and dozens of different models. The European model is actually a private model. The GFS is the North American model, and that's National Weather Service. You can get a lot of that data free at European because it is a commercial model. It costs. So we pay to get that data, and that's in large part thanks to all of you. So this is one of those products that we're able to look at. And what this is showing is that it's not saying that out here in the southern Rockies that things are going to be hotter than over here in the southern plains, but just that it's going to be that much warmer than average. So to reiterate about model data again quickly, how models are built is that they try to break it down into grids, and they take information from surface observations, those balloons that, the weather balloons, you know, that get lamed for everything. And they build a grid from all that data, and then we know basic physics, fluid dynamics, then each one of those grid points should move in a certain way. But if you look at this grid that I put together, and this is just kind of made up stuff, but the spacing though is based on what the medium range models pretty much use, and that's 13-kilometer resolution model. Here we are here in Pagosa. There's Pagosa Peak up here, and in between you only really have a couple of plots. So it could be that the model is missing the coldest spot, the warmest spot, the driest spot. So then as you take those plots and you start moving them out, you're going to have some inaccuracies. And the further out you move them, then the greater the error. So this is how model resolution looks. Sean and Mark and I are pretty good within the first couple of days of forecasting the weather. You can tell that that is a horse's patootie, right? As we get out to the 15-day point, that could be a cat, it might be a rabbit. I can't really see it being a horse. So what we're trying to say here, the further and further the forecast gets out, the less accurate it is. So when we're looking at these forecasted charts for July, August, and September of this summer, there could be a lot of error in there. So keep that in mind as we're looking at these things, that it might just look like that. And it's smiling at you too. They believe this is gospel. So again, this is from the European model. This is a July, August, and September chart. This is a 500 millibar chart. 500 millibars is up at 18,000 feet. And that's the level that we as forecasters really like to look at and examine, because it's up and above all the topography. It kind of smooths everything out. We can see where the steering flows are. We can see where the upper level ridges and the upper level troughs are that really drive the weather in the upper levels. So in this particular forecast, one of the ingredients you need is a strong ridge of at least 5,950 meters. And in this case, that's the 5,888 line, 588 decameter line. So this is a weaker ridge that's already building forecasted for July, August, and September. And note that this ridge line is just to the west of us over the Four Corners area. Because the other ingredient that we need has to do with the ridge placement. This was a study that was done by New Mexico back in August of 2006, showing the ridge line where we would like it. The Southern Plains, up into the Dakotas, all the way up into Canada. Big, strong ridge, that's a 5,900 number there. And the result, this is showing all the rain that fell in the month of August 2006. And you'll see we are up here in the blues and the purples. So for the month of August 2006, we had 4 to 12 inches of precip in Archuleta County going up into the San Juan Mountains. That's phenomenal. Remember that our average for the entire monsoon season over 3 months is 6.25 inches. Now, if we move that ridge a little bit to the west. So now, this is from July 2008, showing the ridge over the Four Corners area, which is kind of what the European model is forecasting for us this summer. The result is here. Now we're in the yellows and greens. So we were looking at like 1 inch to maybe 3 inches of rain falling in Archuleta County and up into the San Juan area in July of 2008. And the reason for that being is that when the ridge builds this far to the west, rather than those storms coming in directly to us, as they do when the ridge is to the south, see, it's coming around, boom, right to Colorado. Boom, right to Colorado. But if that ridge bar builds too far to the north, to the west, then they end up coming at us from the northwest. And so you just have to remember the orographic lee side effect of showers and they tend to dry out as they get here. It's not saying that they won't happen. They will happen. But again, only this side of the room is going to see any rain from showers that come in that way. So the other ingredient that we look for is high surface dew points. And this is the big difference between like what's happening now and what starts happening in the monsoon season. In the monsoon season, we're looking at that deep, deep tropical moisture coming into our area. This is from a couple of years ago, starting like in June. You can see that the red line is the average dew points in each of these areas. Here down in Tucson, it was very dry into June. And then you can see the monsoonal moisture starting to wrap in, and those dew points go above average. And that was true in Albuquerque, Flagstaff, Phoenix, and El Paso. And we track those on a regular basis as we get into monsoon season, because it takes a little while for that moisture to vent up into our area. So the result is a beautiful monsoon. This was from last year. And you can see later that day we ended up with this big patch of thunderstorms came in, and everybody in the room got rain. So now I like to play investigator. So I'm looking at all the evidence that the atmosphere is giving us as to whether we're going to have a good monsoon season or not. And there's several different things that you can look at. Believe it or not, we can look at the Arctic oscillation, even though it's all the way up there. When it is positive, it's spinning very, very fast. The polar front jets tends to stay north, and then the subtropical ridge can build up without being counteracted. When it starts going negative, then we tend to be cooler down here. The polar front jet has a more southerly track. We tend to be cooler. We tend to still be seeing weather, but the monsoon with that deep tropical moisture is not going to set up. The next evidence thing we look at is tropical cyclone activity. And in order to look at the tropical cyclone activity, we're looking again at this El Nino, La Nina fit, right? So this is showing the different sectors off the South America coastline that they monitor on a regular basis, and they have found that sector 3.4, for whatever reason, the waters out there in the Pacific, as they cool and as they warm, have an impact on the weather in North America. So this is a chart showing that in June of last year we were cold, throughout the winter it was colder, and now finally 3.4 has started warming up. And that's why they're saying that we are going from a La Nina that we were during the winter to a neutral, then that by this summer we will be in an El Nino pattern. This is showing every 3 months, like this is July, August, and September. The big red line is the probability is 90% that will be El Nino by that time frame. So what does that mean for us? So NOAA finally came out with their official hurricane forecast a couple of days ago. The hurricane season starts tomorrow. And guess what the first named storm is going to be? Arleen! Yes! So,
I heard you coming.
yes, exactly. So there's a couple of different things to consider here. First of all, we have to consider the water temperatures. The Atlantic is warmer than the Pacific because we have Gulf Stream waters that are coming up here and warming things up, whereas out in the Pacific we have the Aleutian waters are cooling the Pacific waters. So your hurricane season is going to start much sooner over in the Atlantic than it is in the Pacific. The other thing to consider is with El Nino, your waters are warming. So for hurricane formation, that's good. However, with the El Nino, you're also looking at increased winds, and that causes shear. For hurricane formation, they don't like shear. It cuts them off, it cuts them down. It's a braking mechanism for hurricane formation. So the official forecast for the hurricane season is 12 to 17 named storms, and the average is 14. So it's right in there at average. And we're not going to actually see a tropical storm charge up the Gulf of Mexico and come into us. But what we will see with those main storms is they get over into the Gulf of Mexico areas, that deep, deep tropical moisture being caught up into that monsoon cycle, and the moisture will be ejected up into here. Meanwhile, out in the eastern Pacific, the El Nino pattern causes less shear. So out in the eastern Pacific, we have to probably wait till September till those storms really get going, because remember, waters cool and warm faster, slower than land. So the eastern Pacific isn't going to be warming up until September. And so once we get into September, then those waters are going to start generating these tropical storms as opposed to early in the season. So for the eastern Pacific, they're saying above normal season with 14 to 20 named storms, and the average usually is 15. So it's looking good for the eastern Pacific to have a good tropical storm season. So the next piece of evidence that we look at is how our spring snowpack was. Yes, sir.
I mean, on your last slide, you had a thumbs up. Does that correlate with the potential for a good monsoon season here, or is that just related to?
Oh, the thumbs, I forgot to mention at the beginning, the thumbs are mine, and every time you saw a thumbs down, you're supposed to boo. So, okay. So the Arctic oscillates, because we like to see a good monsoon, right?
Yes.
If we have a weak monsoon, then we can go out hiking and we can do the 12ers without worrying about thunderstorms. But then we have to start worrying about fire season. So, I love a good monsoon. Y'all learn so quickly. So, the other thing of evidence that we look at is the snowpack as compared to the wet monsoon. In this study that was done by New Mexico, and then I tried to do one here for Colorado that we'll look at very quickly, is that in saying that you have a deep, deep snowpack, it's taking time it slows things heating up down. So in order for a good monsoon, we want a big, strong ridge. And in order to have a big, strong ridge, we need really, really warm, hot conditions. So if you have a good snowpack, that doesn't necessarily correlate to that. So, hold on. So this was a study that was done by New Mexico looking at July and August rainfall anomalies, saying that, okay, if you're on this side, you had rain, a good monsoon. And up in looking at this is saying that you had a good snowpack. So you can see that there is a correlation between having a good snowpack and less than a weak monsoon, as opposed to having a weak snowpack, but then you had a good monsoon. There's a couple outliers. We always like to look and see if there's outliers. And, you know, in the study that they did, there was really no incidences where there was a weak snowpack and then a weak monsoon. So I took all that data and, so somebody else did a study and they took all the data from New Mexico and Arizona about the snowpack and their sorts of monsoons, and they came up with this information showing that on average, when there was a wet winter, there was also a weak monsoon. And when there was a dry winter, there was a good strong monsoon. So it's fascinating, but boo. Because this year, we had in April a snowpack of 179%, and in May we had a snowpack of 196%. Yay for the snowpack! And there's just a couple of quick figures here. In 2019, because this is busy, and I'll have this out in the post too for those of you who want to study this more. in 2019, when we had a really good snowpack, 168 and 182 into May, we had a weaker monsoon, 5.14 inches. Remember, the average is 6.25. So in 2022, remember we had all that red dirt that fell with the snow? And then our snowpack fell like on a cliff. So by April, we had 93%, and by May, we were down to 54% snowpack. So weak snowpack, wonderful, beautiful monsoon. So I threw all these numbers into a little diagram there as well, and there's just no rhyme or reason. It doesn't quite correlate. But I'll keep studying this because this is only like 20 years worth of data, and the big picture of weather, 20 is not that much. So as we look through these charts, these are the long-range forecasts. These are done by supercomputers, and so we could be looking at a horse's ear, or we could be looking at a pig's tail. So this is the Climate Prediction Center's outlook for July and September, and that is saying that there's equal chances of us being below average for precipitation, which remember for us is 6.25 inches for 3 months period of time. The Euro, is looking at us being fairly dry, a lot less than average for the entire state of Colorado for the months of July, August, and September. The Canadian model is thinking that we're going to be wetter than average, and this really is a very good example of how do you put trust in these models. And that one of the other things that when we consider models is that we don't know how much weight that they give to different things. There's a whole bunch of climo data that's in there, but it might be that the Canadian model puts a lot more weight into the climo data as opposed to the European model. The other thing that models have loaded into them is topography. And certainly when we look at Pagosa, we're very concerned with the topography and how the weather is impacted by that. So some models, their topography is more smooth, and other models, it's very, very detailed, and it has very high resolution topography that is loaded up into it that they take into consideration. So my forecast for the monsoon this year. For July, we're going to have below average precip. The tropical ridge will set up, but we're going to be seeing mostly thunderstorms out of the northwest. August is going to start out slow as well. I believe that it will start picking up into the month of August. I'm hoping, just because I like the rain and I like a good strong monsoon, that ridge will retrograde back to the east. If it does that, then it doesn't matter what I've said, what the European model or the CPC says, we'll have a decent monsoon. September, we're looking for above average precipitation, and that has to do with the Eastern Pacific having good tropical storms. They're not, as we get into September, the monsoon starts to sputter a little bit, so they're not going to be everyday sort of thunderstorms. But as I said before, when we get a good monsoon going on and everybody's getting thunderstorms, there's always those people left out. When we get Eastern Pacific storms coming in here, or from Eastern Pacific tropical storms, everybody is going to get rain, and everybody is going to get a lot of rain. It's the sort of storms that start in the morning, you get the nocturnal storms overnight, and the lightning splashing around it everywhere, and Mark is getting wonderful pictures. So that concludes my portion of the monsoon brief. However, Mark is going to talk to us about lightning safety, because with thunderstorms comes lightning.
Oh, thanks. I like this, you just Do that, and then this. Okay, cool. I didn't get a little tutorial on this before I came up tonight. Okay, so lightning. One of the really cool things about lightning is the spelling and misspelling of the word lightning. Do you know it is the most misspelled word of all of meteorology? Most people, or a lot of people, spell it L-I-G-H-T-E-N-I-N-G. Now, if that's the case, I was struck by lightning 20 years ago. So there is a big difference, and when you're trying to do a post or something, try to get it right. Otherwise, you're just saying, well, it's getting lighter outside, as opposed to it's lightning. Okay, all right. I attempted here. Oh, we went wrong. All right, so total lightning strikes. This is a chart that shows per square mile how many times an area gets hit by lightning per year. I think that's right on this chart. And as you can see, no surprise, Florida, Texas, Oklahoma, and then of course along the Gulf Coast, you have a lot of lightning. Now, as you get out toward the west, we're in kind of that red zone. Let's see, here we go. Ah, there we are. A little bit. Okay, so we're kind of in this red zone. So we get a fair amount of lightning. Oops, wrong way, sorry. Okay, and Arleen put a little star there, so now I don't have to do the laser pointer. But you can see that we are in a fairly high zone for west of, on the other side of the range. Now, what's really...
It's in there too, Mark.
What's that?
Go back just one slide
Okay.
quickly. You can see all the pink colors? Those are the San Juan Mountains. So up and over the mountains definitely is getting more intense thunderstorms and lightning associated with that as well.
Very true. Yes, okay. This is also interesting, showing that even though we get less lightning than some other states, we have a higher lightning fatalities weighted by population based on this chart. And, we can kind of understand that because we also have a lot more people outside. And in some of these other states, the last thing you want to do is go outside in the summertime because you die. And by the way, I was going to mention when Arleen was talking about the monsoon setup, essentially, if Texas gets what I call the hell high, we have a good monsoon. It's a beautiful thing. It's a beautiful thing. So any of you from Texas, I'm from Texas, when we had the worst summers, like last summer, it was a good thing for us. All right. Now, you'll probably not be surprised with this. Guess when the best time is to get struck by lightning? Yep. It's around noon to 2 o'clock. So, is that when we all plan to go on a hike to Pagosa Peak? No, we don't. Well, we might if you want an entertaining kind of a hike. But this is not a good time to go. And unfortunately and fortunately, our house is situated by Coyote Loop, and I get to look outside at all the people who don't know this. And they're out in their flip-flops and their shorts, and all of a sudden, they didn't read any forecast. And, they're at that point where they're near our house, they're at least a mile away from the trailhead. And here it is, big, huge monster storms, and they're just clueless. And I've actually seen some people, it gets pretty scary. We get the hail, and then it drops into the 40s, and they're in their shorts and flip-flops, and they're wet. I'm like, do you guys ever make it to the trailhead? All right, now, you guys probably all know about this, but when there's thunderstorms around, where's the worst place to go? Out to the mountain, right? Yeah, you don't want to do that. So basically, you want to get as low as you can. Hugging ponderosa pines, probably not a good idea. And in fact, if you're out in the middle of nowhere and you have been caught, you didn't read the forecast, going into a ditch is probably your best option. Now, I say that, but if it starts flooding, then going into the ditch is probably not your best option. This I found really interesting. I saw this the other day. So the highest risk of being struck by lightning is actually not during the thunderstorm. Because guess what? During the thunderstorm, you're usually running for cover. So most people are getting struck by lightning right before the storm comes in because they don't understand that lightning can be 5-10 miles away from the storm and can hit you, even though you're like, well, it doesn't look that bad here. And then it's the other thing. Okay, so the storm goes over, you go, well, I'm going to go back outside and do my hike. And then zap, you get hit by lightning. So before and after the storm, we definitely don't want to forget that these are key times to be, to be concerned about getting struck by lightning. Now, this is a really cool thing that some people know about, but let me get my laser going here. So if you go to the National Weather Service and then you put in, say, just Pagosa Springs, and you get the forecast, okay? Now, what's really cool though is most people don't know about this little magic box over here. And in this magic box, when you put in your zip code, it'll have a little green square showing you where you put your zip code. But believe it or not, you can go on here and you can use your cursor. You can go to the minus, make it a wider area, or zoom in. But you can move that green box by clicking wherever you want to, and you will get probably a different forecast. So if you're going to go hiking, let's say in a couple of days, to Grand Peak, if you can find Grand Peak on this, which good luck, but anyway, theoretically, if you can find the area that you're going to be hiking in, you can drop that green box right there, and you will get a forecast designed for that area. So this is real helpful for all of your hikes, because you're going to find that obviously if you're up in the mountains, it's going to be a different forecast than it is in Pagosa Springs. So a neat little trick there for you. Obviously, different apps are great, assuming you can get connectivity, which we all know around here is real challenging. But assuming you can, we love Radar Scope. We also like WeatherBug for their lightning products, because they'll actually show you graphically, and WeatherBug actually puts like a little bullseye and will show you how many miles away the lightning strike was and where it was. Okay, now, I'll do the radar thing. I do have some bumper music for this. It'll only take a second. Let me get my phone going here. Okay, ready? All right, that was my little bumper music of Radar Love. We would love to see a radar here, wouldn't we? As opposed to getting blinding blizzards, and you go out and you look at your app, and it says, oh, the birds should be chirping, and there's nothing happening at all. And you're like, wow, what's going on? So, unfortunately, we are in a radar, I think, Arleen's, she's being really kind. She's calling it radar weakness. I call it radar black hole. And unfortunately, we're about 200 miles from Grand Junction. We're about 200 miles from Albuquerque. And those radars, even though they're great radars, they're only seeing storms that are around, what, is it 20,000 feet? Is it
25,000.
25,000, okay. So in the summertime, we can kind of see one that's coming our way, but what's really funny is that, as they move away from New Mexico, if they're coming from the southwest, you'll look on it and say, oh, it's weakening, no problem. Then all of a sudden you're getting hail and high winds and heavy rain. But, so that's the problem we have. We're in between these radars. The National Weather Service has said, no more Dopplers, at least in the foreseeable future. So what's happening is certain cities and towns are buying their own Dopplers. And there's actually some wealthy people in New Mexico and Texas that actually put them on their own ranches. Because you can actually have your own radar for about $500,000. And if you got $500,000 lying around and you want to have a radar, you too can have one. So anyway, Alamosa a few years ago, they got their own radar. And I think they're spending closer to like $1 million for it. But we have access through this, what's it called,
MRNS.
Yes, and we have that on the site, right? Yes.
So if you go to our webpage and go down the left hand under resources and then go to radar, you can go to MRMS and you can look at the Alamosa data. It's a little But we have that available on our webpage.
Okay. And so they were upset that they were not covered. They gathered the money, they got the grants, and they put in their own radar system. Durango decided to do that about, what, 20 years ago now? It seems like it. I think it was like 3 years ago. And I just talked to Ted today about it. Let me move ahead here. Okay. So eventually, when Durango radar comes online, we will actually get a pretty good reading from it. I mean, it'll actually hit us pretty well. And so it will help us a whole lot, especially as storms are coming in from the southwest. Now, backtracking, I talked to Ted today, and he said that they're supposed to start construction on the actual Doppler at the airport in June. But get this, weather pending. Okay, well, great. Okay. Weather that we can't see on the radar. So, anyway, all the infrastructure is in at the Durango airport. They're just, and then the Doppler's supposed to be shipped out there. The company that got the bid is called Barron Weather, and so they will be actually making or installing the radar. If you want to hear about sort of the status and some more information on it, if you Google Durango local news, they have this little news station, like a web news station, but they actually have an interview with a guy from Barron Weather, and he talks about the Doppler radar. So I saw it today. It's about a 5-minute YouTube, and it's really, it's pretty neat stuff. So the thinking is that they will have it in place by the end of this year. They hope to, he said, the best case scenario would be fall. It might be up, but more than likely expected to be the first part of next year. Hopefully it won't be too late next year, so we can use it in the wintertime. Yes?
So do the communities like Alamos and Durango that roll their own,
Yes.
do their feeds then get incorporated in national weather?
That's a really good question, and we're still trying to figure that out.
NRMS is a National Weather Service program. It's the newest National Weather Service radar feed. What I cannot get any answers from, and talking about the National Weather Service and the folks over at Durango, is that data can be fed into these weather apps that we have. Radar Scope, Weather Bug, and so forth. So we'll just keep pressing to get an answer on it. And
Right.
I don't know if it's just because they haven't had the foresight to think of it, or is it the money?
But it would certainly be.
Not under our control, so we don't want to add their data to our national weather service. So,
That data will be added to the National Weather Service.
The question is the apps.
The
Right.
apps.
Now, guys, I'm trying, does Alamosa show up on our, like the weather app? They don't, okay, I haven't. Okay, so the only way you can do it is on your computer, or if you have a link on your phone, right? That would be, okay. Okay, we're going to briefly just talk a little bit about our phone Monsoon. So our website, as I told the people at the library, if you have several hours, you can get a glass of wine, you can just put some nice music on the background, but you can spend a lot of time on our website. Sean and Arleen have done a fantastic job of putting the very best links, all kinds of information. And you can also subscribe to any of our updates and get them via email. That way, in case you forget to check or you're not sure, you'll get a neat little email that comes in, and it'll have our latest forecast. And then on it, you have things like webcams. You get to see the view out of my backyard. I have one aimed at Pagosa Peak, and it runs 24/7 unless my laptop says, oh, I'm going to reboot arbitrarily. And that only happens when I leave. So within an hour after I go on vacation, that's when that unfortunately will stop. But there's a lot of cool stuff, and we've got our summaries, historical data, satellite stuff. I mean, it just goes on and on. And like I said, just spend time, just click, just keep going down. You'll find some really cool stuff. weather models, Weather 101. Okay, well, that's it for lightning and radar update. I'm going to pass you over to Sean, and he's going to show you the really cool rain gauge.
All right, guys. I always forget this acronym, so I'm just going to read it. This is Coco Ross I want to talk about. This is an official program. These are official rain, hail, and snow network measurements. And what makes this official is, number one, we all do similar training online, and we all use similar equipment. That's what makes it official. And this data is used by a whole bunch of people, including climatologists, your agricultural folks, your hydrologists, media people look at this data. It's all over the country. It started here in Colorado, and it has expanded tremendously. I'm proud of us here in Archuleta County. We have very good representation, but as always, we can do better. I have highlighted a few areas we'd love to have somebody doing Coco Ross measurements, especially the western part of the county is a data black hole. We have no idea what's going on over there. And we're begging all the time. So if you guys know anybody over there, and we'll try to set them up with one of these. These online cost $35 to $40. And we
Mike snowboard.
yes, and I wanted to say that too. Where's Mike? Oh, there he is. Yes, thank you, Mike. Yeah, we went to Mike earlier in the fall, roughly in the fall. We said, we need snowboards. Hold it up again, please. This is a snowboard, and that's what you measure snow on officially every morning. So every 24 hours, you poke a ruler in that thing, you kind of do a quick measurement, you either clear it off or you just flip it over.
Unless the wind blows it all the way over.
This was out all winter long, and you can barely tell. Mike did a fantastic job. And Sean and I will have a training course in November for those of you that volunteer to do Coco Ross to teach you how to do snow measurements, because it's easy when there's no wind. But there are tricks of the trade when there's wind.
Yeah, during the summer, the whole program is real easy. You go out, you just look at your gauge. It falls here in the funnel. It comes apart like this. You have a measurement in here. So you just look at that, and then you dump it, and then you throw it right back in and push it out. And then you can update it either on the app. It's real easy. We actually prefer to send our data on the app. It takes us, 30 seconds usually on the app. You can also do it online, log in online. In fact, how many Coco Ross observers do we have here now? Yes. Okay, thank you very much. Yeah, you guys, a lot of people use that data, especially we look at it daily, and like I said, it's official. This isn't what your digital gauge says at home. This is more official data than a lot of those digital gauges.
The digital gauges during the winter don't melt the snow, so we don't get any information during the winter. And if we have heavy showers, a lot of the digital gauges aren't able to absorb that much moisture. A lot of it ends up just slipping out on either side before it actually gets measured. So the Coco Ross is very accurate.
All right, anything else?
No, so this is our schedule for those of you that are interested for the next couple of months. We have an outdoor club meeting on the 31st. The 4th of July, we are going to be in the 4th of July parade. Mark is going to be driving his beautiful blue Jeep. Sean and I are going to be running along and passing out stress balls. They're in the shape of clouds. And then we're going to have a couple of folks along passing out candy. And one of our wonderful board members came up with the idea of maybe 4 people dressing up in seasonal garb, like for winter, maybe as a snowman carrying a flag, So,
We found a volunteer for that position.
no. So we are looking for volunteers, those of you that are friends of Pagosa Weather that would like to do the 4th of July parade for us. You'll notice, Mark, Sean, and I have Pagosa Weather t-shirts. You can only get a Pagosa Weather t-shirt if you are a sponsor, or on our board, or want to participate in an event with us. So, if you would like to volunteer and come along for the fun of the 4th of July parade with us, you get a Pagosa Weather t-shirt. So, we'll also be out for the Color Fest, briefing the pilots and so forth. And then for the Chili Cha-Cha, we'll have a weather boat set up for that. And then we have a beautiful tree that we're planning for the Festival of Trees in December, for those of you that might be interested. I think I've got 400 snowmen and snowflake ornaments so far. And if you would like to donate more, that's great. We already have a tree as well. So. So that concludes our brief this evening. I would like to thank all of you for coming out in the rain. And if any of you have any questions, Sean is still here to answer all of them.
Questions?
Awesome.
Oh,
In the back, sir.
And you had the, I guess it was the Canadian forecast on display for a while, and it showed the different color sequences through there. I'm just curious. I think Pagosa was in like the light. Yeah, it's that one right there.
Yes, sir.
What is the brown and dark brown? What does that do?
The color lines are saying either average. If there's no color, then that's average.
Okay.
Or the brown is saying less than average. And the green then is saying wetter than average. So we're into the green over here. And again, I'll have these on my post that I make so you can look at it in more detailed information. And I'll also have links out there so that you can go and look at this information in more detail. Does that help?
Yeah.
Yeah, and to be more specific, so the dark browns are much below average, and the blues are much above average. So that's the scale. I just wanted to point. Another interesting thing about this, and I talked to the climatology guys about this. So, this may not seem impressive compared to a lot of the other places, but keep in mind 90% of this happens during the monsoon. So all those lightning strikes that's there on that, I think you see, the scales on this one. You know, so you're up to, I don't know, 32 to almost 100 per square mile. That all happens during our monsoon season, which is really impressive. Because those other countries, you know, those other states, can be all any time of year, especially Florida. That's all year. All right. Any other questions? Yes, ma'am.
Do you still have a lot of lightning strikes through the week monsoon?
Yes, definitely. We always expect a lot of lightning strikes. In fact, it was pretty active this last round of moisture. We're aware of some people who had very close calls or even got hit recently.
Yeah, with a weaker monsoon, then you can expect, and in the sputter phases as well, they're going to be drier thunderstorms, so they're going to be higher based. And so then think of the air that is coming out of the top of the thunderstorm as it's coming down into that dry air below. The greater the distance from the ground to the base of that thunderstorm, then the more that air is going to fall. So the thing with the higher base dry thunderstorms in a weaker monsoon is that you're going to have more winds and more dangerous winds. As opposed to when we get really, really moist, then we don't get that much as far as wind. Yes, ma'am.
At our house today, we had some hail preceding the rain. Is there a way to forecast what's going to happen with hail and maybe worry about hail damage?
So that will come with radar to some extent. However, radar is what we call a nowcasting tool. That helps us within like the next half hour to maybe hour. So even then, so yeah, we can see a thunderstorm pop up in here. Let me go backwards a little bit. One of the interesting things about our thunderstorms in this area is they're very short-lived. The whole process from development to mature to dissipating is 90 minutes to maybe 2 hours, the entire process. So it happens very, very fast. So if somebody was babysitting a radar 24/7 and saw that cell pop up in that 2 hours, we could say, yeah, in this narrow area, over the next half hour, you could get big hail. But right now, our abilities are not, we're not there, especially not in this area.
And Sean, let me, on that radar that we like, the MMR, whatever it is.
MRNS.
Yeah, I'll get that right. There's this neat little feature on the left-hand side where you can go in and you can ask it to show where hail is. And I use that a fair amount. I have a page in South Texas where they actually have it a lot more often in bigger ones, but it's really pretty accurate. So if you were to get on that radar and if you see that cell coming towards your house, you can click on that hail feature and it'll actually show you a little spot where the radar thinks there's going to be hail. So that might help you, but that's only if you're at home and you're at your laptop, but it could give you a little heads up on that.
In order for hail to form, you want good updrafts. So you want for that raindrop to reside up in the top of the thunderstorm for a greater period of time. So you get that coalescence going on, and that's what builds the hail. And so when we're interrogating radar, if we had it, then we're looking for a weak echo rate area inside of a cell. We look at it in the vertical.
I
And
see
then-
Sean's, yeah, go ahead.
Yeah,
So that's where the potential is there.
Yeah, here's the MRMS, and this is about the only way that we can get, especially the San Luis Valley data. This is the only place we can get it. So I have this open always on my phone and always on my laptop so I can see. And you can see here, you gotta hit current time like Arleen said, or she might be looking at old data, and it will update automatically. And what Mark was saying is, it gives you all these capabilities over here, and it is pretty good. But keep in mind, in our area, again, you're only looking at the top part of that storm, 25,000 feet and up. So even that is a little tricky. Now, we do see when people report, let's say, marble-sized hail here, MRMS does a decent job of picking it up in our area. If it's much below that, then we're kind of guessing. So, even just looking at this is just a basic reflectivity, but this cell down here looked pretty impressive. And I'll bet if we look, and look how quickly it pops up. It only goes red there at its max for like 2 frames, and then it starts dissipating. So things happen in our region very, very fast. That's when you're out in the wilderness. Not only look around you, but pay attention to what's going on overhead. If that cloud is getting bigger and darker, you're in trouble. Things will happen fast.
Sean, just for fun, hit the hail lightning to see what it does with that storm and see if it actually pops up.
Let's see, where are we? I like Bill.
Vertical.
Bill's one of my favorites. So this is a different way of thinking about lightning. This is telling you the vertically integrated liquid within a storm. And yeah, that's all kinds of trouble there for that area. That's probably
But it's already
quarter-size hail and all
As
kinds of
those
fun
colors
stuff.
are going away, that means that cell is dissipating and everything is rushing down out of it. It's
But
over.
it did have hail. I mean, it looks like it did.
Probably.
Yeah.
Probably with those sort of colors, yeah.
Yeah. There it goes.
So, yeah, just, and again, look, it maxes right there for about 2 frames and then poof, gone. So to go back to the original question is, even if we have this and we have good radar and we're watching it, you're still not going to get much of a warning. I think the standard, and we asked this recently, the standard for tornado warnings is, I think they're hoping to provide 15 minutes is the standard. That's about the best we can do in most cases.
And that hasn't really improved. The number of warnings has improved with Doppler radar, but that lead time has not really improved even over the last 25 years with Doppler radar. Ooh, clouds.
Any other questions while this is loading? All right. Anybody know what the line is between the light and dark? Now, once you hear this, you'll never forget it. Go ahead, Arleen.
Oh, that's the sun, it's nighttime.
So mine is the Terminator. Yeah, it's the Terminator.